Hello, Professor. This is Julia Schneider, and today I'm going to be recording my fourth video correction. This is on test 2, and this is about learning target D5, which states I can compute derivatives using multiple rules in sequence. I had the right idea for kind of, but I complicated it way too much. But, I mean, look over here. This was the right idea, you know what I'm saying, for some of it. So, I guess I must have just been quite tired. I don't know. So, let's jump into it. So, the first problem says that S of t equals t squared plus 3 over 4t natural log of t. So what I didn't do is use the product rule correctly or at all. I don't know what I did. So let's solve it the correct way now. So here we go. First, this is something I learned in your class, and it's something I really love for organizational purposes. So the derivative of the numerator is 2t, and the derivative of the denominator, using the product rule for both terms, is 4t times 1 over t plus natural log t times 4, and this equals out to 4 plus 4 natural log t. So yeah, and now that we have this properly, we could plug it in using the quotient rule to this equation, which is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So now we have it plugged in. We have our power rules used right here. We have the product rule used right here, and we have the quotient rule used right here. So that is 3 rules in sequence. And yeah. Now let's get into the second problem to solve, which is h of x equals 10 to the power of x squared times e to the x. I don't know what the heck I was on about over here. I was one confused lad. I must have just gotten freaked out. I don't know. Let's just jump into it. I did get the rules to use correctly, but did I use them correctly? That is another story, and the answer is no. So here we go. This is the correct way to solve it. Super simple, much more simple than I thought. So h of x equals 10 to the x squared times e to the x. So h prime of x, so let's take the derivative. We use the chain and the product rules and the power rule right here to get 2x. But first we take the derivative of the exponents. So we take this whole first term and then natural log of 10. And then we want to use, so this is the chain rule, and then we want to use the product rule, which, is like we set up here. To figure out this part. So we take 2x times e to the x plus e to the x times 2x. X squared. And so we have the correct answer right here. Amazing, super awesome. And I just said here, I don't really know, but I mean, it's pretty obvious, but yeah, it's the first term times the derivative of the second, plus the second term times the derivative of the first. And so yeah, now let's get into the last question to answer, letter C. And this says b of y equals log 5 times 3 minus 2y all over 4y cubed. So I am super confused on regarding my response. Let's just jump into it because I don't have a super long time. But yeah, so this is C, and we're going to use the chain, power, and quotient rules to find the derivative of this. So here we have the equation again, and taking the derivative of the top and the bottom, so f of x and g of x, f prime of x equals 1 over 3 minus 2y times 1 over m natural log 5, all times negative 2. And then the derivative of g of x is obviously 12y squared. And this is what I messed up on my, that's the first part that I went wrong. And so then b prime of y, taking the derivative, we just use the quotient rule, and we set it up. So we take our, we take all of our stuff and we put it into the quotient rule formula, which I have previously discussed up here. And so, yeah, this is the final version. And I hope that this is fully correct. I hope with all of me. So, yeah, hopefully this is a good explanation and a good video. And yeah, these I find to be really enjoyable. When I redid a bunch of them before I did this video, because I mean, when I first got this test back, I was like, oh, okay, I mean, I know I did really wrong, but I wasn't really confident of the correct answer until I did a bunch of the practice problems over, and I had a lot of fun. So that is, I'll probably bring these to the beach next time, do some more, and yeah, thank you for watching. Have a nice day.